This is Josh White with JW Math Tutoring. In today's video, I'm going to go through Digital SAT Linear Paper Test number 8, Math Section Modules 1 and 2, specifically the unique questions that do not appear on the Blue Book exams. So let's go ahead and get right to it.
But life is a dream the calculus could never predict.
Just before I begin going through these questions from Linear Non-adaptive paper practice test number 8, math section modules 1 and 2. Please keep the following things in mind. First, if you like this video, of course, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And second, so as I mentioned, these are questions which are from the linear non-adaptive paper practice test number 8. So most of the questions on the linear paper practice test overlap with Blue Book. However, there are some questions that do not. Okay, so these are those questions that do not overlap in Blue Book, or as I call them, the unique questions. So in other words, these questions I'm going through today, completing them, working on them, finishing them, has no effect on any Blue Book practice test because you're not going to see these questions on a Blue Book practice test. These are unique, like I said, unique questions that don't overlap. Whereas the other questions in this linear paper practice test 8 do overlap with the Blue Book test. Okay, so just keep that in mind. Another thing is there's a PDF, there'll be a link to it in the description, which has all these questions that you can just download, and work on right away. And also check out the videos for the other, linear paper practice test unique questions. Basically, 7 through 10 is what I'm working on first, and then the older ones will be up as well. All right, so with all that said, let's go ahead and get started now. Again, we are working on linear non-adaptive paper practice test number 8, the math sections. We're starting with module 1. And the first unique question we have is number 5. So for this is basically a survey, type question. And the whole idea is the mean for this carton of tomatoes is 4.23, and they tell you the margin of error is 8 cents. All right. So which of these is plausible? So the only one that makes sense is letter A. Like essentially, the margin of error tells us, how much above the mean, so 423 plus 8 cents, and how much below the mean, we would expect the actual true mean to be located, in that range. So basically that's, 415 to 431. These other things, being less than 415, no, doesn't make sense. Being greater than 431, no, but either less than or greater, no. It's between those two values, between the range. So the correct answer for this would just be letter A. Next up, number 6, you have a very simple basic equation to solve. We're just going to subtract 2.6 on both sides, and you will get 0.2. Now, there's technically multiple ways you could enter this in the test. You could do 1/5 as a fraction. You could just type in 0.2. You could type in 0.2. All of these would be considered correct. Also, you can go to Desmos and you can solve this in Desmos, but hopefully you don't need to do that just by typing the equation, and then you'll see a vertical line at 0.2. Because this is such a relatively basic equation, I'm not going to spend time demonstrating that here. We'll look to do that on, other equations. All right, next, let's talk about question number 23 here. Let me see. I can't quite get all the answer choices on, so whatever, we'll scroll down as needed. All right, so here we have a frequency table. It gives us a bunch of values in column 1, and then it gives us the frequency, i.e. how often they occur, in column 2. All right, and this is 71 total values. Then what they're going to do is we're going to add one more value to a new data set. It's basically the original thing plus, this other one. And it is a value of 39, and of course, and the frequency would just be 1. Okay, so how do we compare the mean and median of these two data set values? So, excuse me. First, I'll show you the theoretical way, then I'll show you how you could actually do this in Desmos to calculate the actual numbers. So theoretically, If you just calculate the mean from these values, it's going to be something, between 13 and 20, right? Now, when you add a much larger number to the data set, so in other words, when you add a number 39, which is greater than the existing mean, which is between 13 and 20, the mean is obviously going to go up. So in other words, the mean for the new is going to be greater than the mean for the old or the original. So if we go down here just to start off, okay, let's see. The mean of the new data set is greater than mean of original. Okay, that we keep. B we keep. Mean of new data set is less than mean original. No, wrong. That's the opposite. Mean of new data set. Okay, wrong. That's the opposite. So now we're down to these and we're comparing the two medians. So here's the way I would look at the median values. Basically, for the original, we have 71 values. Okay, divide that by 2. That comes out to 35.5. You then round that up to 36, and that is the number value, which is your median. So in other words, we're going to go down the frequency column and continue until we get to or past 36. So what I mean by that is 12 plus 8 is 20, and I'm just doing this like a cumulative, frequency. 20 and 5 is 25. 25 and 7 is 32. 32 and 9 is 41. So the 36th value is basically a 17-pound tortoise, okay? So the median for the old or the original is 17. Now with the new data set, okay, so median for the new, we have 72 values. Divide that by 2, we get 36. That means that the median will technically be the average of the 36th and 37th values. So we have to find the 36th and 37th values and find their average, and that's going to be our median. So notice I already went down this frequency column, right? And it jumps from 32 to 41. So that means the 36th and 37th values, they're both 17. So therefore, the average of 17 and 17 is just 17. 34 divided by 2 is 17. So the median of the original is 17. The median of the new is 17. Therefore, the correct answer for this is going to be letter B. The medians are equal. Now, I will show you the one part of this that you can do relatively easy in Desmos is calculate the actual mean values. Finding the frequency for these without, without typing everything out is not very easy. It can be done, but it's very complicated. I'm not going to, bother spending time to show it. So first we have our values, then we have our frequencies. Okay, so I'm just typing everything in a table, basically essentially as it appears on screen. All right, now what I'm going to type is its total of x1 times y1. All right, so that just basically goes across each row and it multiplies the x1 value times the y1 value, and then it just sums them all up for the entire table. Then I need to divide that by the total number of values, i.e. the sum of the frequencies, which is basically just the total of the y1 column. So this is the original mean. It is 16.549. I'm just going to round it to 16.55. 16.55. Now, for the new one, I just have to add a value of 39 and a frequency of 1, and notice now the mean has updated. It's 16.86. It's clearly gotten bigger. So this is one part of the problem you could do if you wanted to, just to actually compare the numerical values for the means and confirm the new mean is greater than the original or old mean. All right, next up we have question number 26. So which of these following functions here displays as a constant or coefficient the maximum value of the function when x is greater than or equal to 0? All right, so the first thing I would do is go to Desmos, and I'm going to graph out these two functions. What you're going to see is that one of them will technically not have a maximum value. Okay, so the first one, now I'm going to put on the qualifier x greater than or equal to 0 here. basically that restriction. Then the second one, again, same thing. Okay, so let's move this over a little bit now. Let's get a good picture to grab. Okay, so notice the red one, the top one, it doesn't even have a max value. It just keeps going, higher and higher and higher essentially to infinity. So the answer cannot be number one because it doesn't even, it doesn't have a max value. So one is out regardless. So this is out and this is out. It's either does two display it or not. All right, so let's get rid of this. Okay, what's the maximum value? Well, it's basically going to be this y-intercept point. What is the value of the y-intercept point? Well, it's just 9 right here. So does the second function, the g of x, have 9 as a constant or coefficient? Yes, it has this 9 directly out in front of it right here. So correct answer is going to be just letter B, 2 only. Next up, question number 27. This is the last unique problem from Module 1 of this linear paper practice test 8. We have an equilateral triangle basically inside a circle. So let's say we get a circle that looks something like this. Let's see if I can get an equilateral triangle. Close enough. Yeah, close enough. Okay. All right, so we know that each side of this equilateral triangle will be 852 divided by 3, which is 284 centimeters. So 284, 284, 284. And they want to know the value of the length of the radius. So like here is an example of a radius, w root 3. Here's an example of radius, w root 3. So what we're going to do is basically we are going to draw an altitude here, height so to speak, of this large triangle. That's going to split the large triangle into two smaller triangles. They're going to be congruent and they are specifically going to be 30, 60, 90 triangles. The reason you know that is because here in this equilateral triangle, we have three congruent sides. Each of these sides is a chord of the circle. In a circle, congruent chords have congruent arcs. Therefore, each arc, for example, here to here, has to be 120 degrees. It has to be congruent to this 120, and it also has to be congruent to this 120. Therefore, the measure of this central angle will also be 120 degrees. Okay? Therefore, if this angle is 120, that leaves 180 minus 120, or 60, to be split up to the other two angles. And since this is a radius and this is a radius and they're congruent, the angles across from them are congruent. Therefore, the 60 to get split up, so this is 30, this is 30, and that's how you know you get 30, 60, 90 triangles. All right, so anyways, with all that being said, let me just do an enlarged kind of picture of exactly what's going on here. So what we have is basically a 60, a 60, a 30, a 30, a w root 3 here, w root 3 up here, and what happens is this 284 gets split in half, okay, because the two triangles are congruent. So therefore, 142, 142. Now, looking at these 30, 60, 90 triangles, 142 is the long leg. It is the side across from the 60. Therefore, to get the side across from the 30, which is the short leg, this right here, we will take this 142 and we will divide it by root 3, because that's how you go from long leg to short leg. So when we do that, then you multiply by root 3 in order to simplify, basically the radical, and you get 142 root 3 over 3. So this yellow side right here is 142 root 3 over 3. That's the side across from the 30-degree angle. Now, to get to the hypotenuse, which is this radius right here, you just take this short leg and you multiply it by 2. So that's going to give me 284 root 3 over 3. This is the length of the hypotenuse, which is also a radius of the circle, which we know is congruent to w root 3. So now let's match up the parts. Okay, root 3 and root 3 cancels. Therefore, w must equal this number right here, 284 divided by 3. So that's one way you could enter the answer, or you could also enter it in as a decimal, 94.66 if you truncate it, or 94.67 if you round it. So either of those three would be an acceptable correct answer. All right, let's move on to Module 2 now. There's only 3 questions, and they're all relatively basic. This is not going to take very much time at all. First, what's the y-intercept of this line? Well, it is just 0, comma 5 right here. Correct answer is letter C. Next, you have a basic function to evaluate, so we can just plug in 2 for x and then do order of operations. 2 to the third is 8. 8 times 8 is 64. Add 4, we get 68. That is the correct answer. That's what you would grid in. Of course, you could also go to Desmos as well, and you could just type in the function and f of 2, 68. There we have our answer. Lastly, you have a right triangle. This is number 12. And in this right triangle, they want to know what the value of sine A is. Well, this is just a straightforward, sine A is equal to opposite over hypotenuse. The opposite side is 35. The hypotenuse is 171. The correct answer is letter B, 35 over 171. That's it. There's no other work. You don't have to find the unknown third side AC. Just plug in the 2 values you're given and get the answer. All right, so I hope you enjoyed this video going through the unique questions on Digital SAT Linear Paper Practice Test number 8. Of course, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you have any questions or comments about the solutions to any of these problems or alternate solution methods, please feel free to leave them in the comments section below. And check out the videos with solutions to the other unique questions from the linear paper, non-adaptive practice tests. I'm starting with 7 through 10 and then going back to the older ones after that.